Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem. Okay, distribute candies in a binary tree. So we will be given a binary tree. Okay, and each node value represents the number of candies present at that node. In one move, one may choose two adjacent nodes and move only one candy. Move only one candy. Okay, one candy from one node to another, and the move can only be from either parent to child or child to parent. Okay, the task is to find the number of moves required, right? Number of moves required such that every node has exactly one candy. Okay, and also note the tasks are framed in such a way that each node will exactly have one candy after some moves. Okay, so let's quickly see this example. So what they're saying is, okay, so now this root has three candies and the children has zero candies. Okay, and we want to calculate the number of moves such that each node has exactly one candy with them, and we want to return the moves. Okay, so now, and what is the condition? We can either move the candies from either parent to child or from child to parent. Okay, so in this case we'll have to, and in each move we can move only one candy. So for example here three. Okay, and let's have number of moves in answer, right? So one candy will be passed on the root from the parent to its left child. Okay, so it will have two candies and it will have one candy, right? And the number of moves will be in order to move this candy, right? It will be one. Okay, in one move one candy. Now it will pass on one candy to its right child. Okay, so it will have number of candies as one, and here it will have one, and the number of moves will be one. So here if you see, the number of moves are two. Okay, which is answer two. Okay, similarly let's see another example quickly. 0 3. Yeah, so here, so it does not have, here the root does not have any candies, neither its sibling has, right? And this left child has the three candies, right? So what it will do, it will pass on two candies. It will keep one candy with him and pass on the remaining candies to the parent. And what will be the number of moves? It will be two, because in each move we can, so we have passed on two candies, right? We have passed on two candies, so it will take two moves, right? So okay, now this root has two candies. Now what it will do, it will pass on, it will keep one candy with itself, and will pass on one candy to the right child. Okay, so it will be another move, right? Passing one candy from root to the right child. So it will be, the number of moves will be three. Okay, the number of moves will be three. So now, okay, so now I hope you've got the problem, what the problem is saying. So now let's see the intuition behind solving this problem, right? So what we'll do is, we will, in like this example, right? So we will pass on we'll start from the leaf nodes. Okay, and we'll pass on the candies to the parent. Okay, we'll keep on passing the candies to the parent. We'll keep one candy with us, with this node, with the leaf, and we'll pass on the remaining candies with the parents. Okay, so now let's see through the code. Okay, let's see through the code. Okay, I have this okay, the Java code here left on the left side, and the C++ code on the right side. Okay, so now what we'll do is, let's have this example, right? 0 3 and 0. Okay, so now what we are doing here is, first we have the base condition is what? If the root itself is null, then definitely we'll have zero candies on, right? So we'll simply return zero. Okay, and then what we are going to do, we are going to traverse the left subtree. We keep on going to traverse the left subtree until we find the leaf node. Okay, so now we move from 3, right? From 0 to 3, right? And then we go to the left side of this leaf node. But here it will hit this base condition and will return simply what? 0. Similarly, from the right child we don't have, so we simply return 0 here. Okay, so here we come here now, right? For this leaf node, we went to the left child and right child, but we got 0 from here, right? So L and R is 0. Okay, and here answer is the number of moves, right? So let's have answer equal to 0 for now, right? Absolute of L, I'll explain this absolute, right, by absolute. L and R, okay, it will be 0 now. Okay, because L and R itself is 0. Now what we are going to, in this step, what we are doing here is, see, now we are adding the number of candies we got from the left child, adding the number of candies from the right child, adding its own candies, right? Adding its own candies, which is 3, right? Which is 3. And we will be keeping one candy with us. We'll be keeping one candy with us, and we'll pass the remaining number of candies to the parent, to the parent, right? To the parent. Okay. So L is what? 0, R is 0, 3 number of candies, current candies, and minus 1, right? We'll keep one with us. So we will pass on, we'll pass on two candies. Two candies. So two candies, right? Two candies, 3 minus 1, 2. So here it will have one candy, and we'll pass on how many? Two candies to the parent. Okay, two candies to the parent. Okay, so here we are now. We are on this node. Now we'll go to the right child, right? We'll go to this right child now. Okay, we'll go to the right child, and we went here. We'll again go to the left child and left child of this, right, of this leaf node, and right child of this leaf node, right? So what we'll get? We'll get 0, right? When this will be base condition, we get 0 over here, right? 0. Okay, the answer again will be for this node. It will be 0 only, because L and R are both 0, right? Right now comes this case, right? Return. Now comes this case, right? So what is L? L is 0, R is 0, current data is also 0. And what we're doing, we are doing minus 1. We want to keep one candy with us, right? And we'll pass on these number of candies, okay, to the parent. Now what it will be? We'll pass on -1 because we don't have any candies, right? We are saying this is the current state. I have when I say -1, we are passing -1. That means it is saying that I want one candy. I want one candy. So we are passing -1 here. Okay, we are passing -1 here. So now this root, right? This root. Now we will be here now, right? We'll be on this step for this root, right? Because we have traversed the left child and right child, and now we are here. Now, what is L? L is 2. We have got, right? And in the R side, what is R? R is -1 we have got. R is -1 we have got, right? So what it will be? Now see, here we are calculating the number of moves. So it does not matter. So that is why we may get -1, right? We get -1. But here we are calculating the number of moves. So how many number of moves it will be, right? How many number of moves it will be? 2 plus absolute of 2, right? We are saying absolute of 2 plus absolute of -1. What is this? 2 plus 1. Absolute of -1 will be 1, right? And 3. We are getting 3 now. We are getting 3. Okay. We are getting 3 now. Okay. 3. That is 3 number of moves. Okay. 3 number of moves, right? So what does this mean? When we say that, okay, we are calculating the number of moves, right? So when we say we are passing -1, that means that means that the parent is going to give, to the child one candy, right? So here the parent got two candies, na? The parent got two candies here. And what it will, when we say -1, right? So how many number of moves will be required? One number of move will be required, right? Such that it will pass on one candy to the child. As it has two candies, right? As it has two candies, it will pass on one candy to the child. Okay. So this will signify the number of moves will be required to move from parent to child. Okay. We got two moves, right? So we passed on two number of candies in two moves, right? So that is why this answer is absolute of L plus R. Okay. So I hope you have got. So this is the three number of moves. Okay. Similar. This is the C++ code, right? It's almost similar. Only we have asterisk here, right? With node. Okay. As a point, this is a pointer. Okay. So here we are doing the same thing. Root equal to null. It will return 0. Then we'll go to the left child. We'll go to the right child. We'll absolute and same. Root plus key plus L plus R, and we'll keep -1. That is to keep one candy with us. Okay. So this is a solution, and this is the code as well. Okay. This is a code. Let's submit this maybe. Let's try this. Okay, so here the cases are passed. I hope you've got the solution. Please subscribe to my channel, like the video. Thank you. And also have a happy, healthy, and great day. Thank you so much.